Hi, future doctors. Welcome to the next class. So, we were discussing electric force between two charges. In that, if two charges suspended by insulated thread, if two charges suspended by insulating thread, like this, then so between two same charges, always repulsive force is going to exist. Because of that repulsion, these two are going to be repelled like this. So charge Q. Up to what separation they are going to move means x distance. Then what is the angle made by this string with the vertical, they will ask. Theta. They are going to ask this theta. So what is the angle made by this string with the vertical, they are going to ask. At the time, how we have to solve the problem. So from here to here we will assume, let us assume it is going to be x by 2. And the tensional force developed within the string. If any object is suspended by string, then what will be developed in the string means tensional force. So for this, we will discuss all these things in laws of motion. Just I am giving now once. If any object is placed on horizontal surface, then what is the gravitational force direction means? Weight is always acting downwards towards the center of the earth. Then to balance this, surface will act opposite reactant force in upward direction, that is normal reaction. So always N is going to be equal to mg. In some people, in some books they will write Kepler also. Normal reaction is always equal to weight of the object when if object is at rest position. Same like that. If you suspend any object with a string, again gravitational force will act downwards. Now who is going to balance this gravitational force means tensional force which is developed in the string. Here T is equal to mg we will write. So within this string always which force is developing? Tensional force. So on surface normal reaction. If you suspend this object with spring, then restoring force. Like that we are going to get. Again we will discuss those. So why I have explained this means because we are using here tensional force. Now this is the tensional force which is making an angle theta. So after reaching here, both the charges reaching positions A and B. After reaching A and B, these two charges are in equilibrium position. Already I said about equilibrium position, null point there. So when it will be, any object will be coming for equilibrium position means if all the forces, how many forces acting on that object, if all the forces resultant force should be equal to 0, or if two forces are acting, those are equal and opposite. Understood? So therefore, how many forces are acting on this we will see. So first, for this charge, what will be there means mass will be there. Whenever mass is there, its gravitational force always acts downwards. Now, who is going to balance this gravitational force? So mg is acting downwards means some force will act in upward direction. So how we are going to get that upward direction means this is nothing but t. So this t is making theta angle here. So if you resolve this t into two components, so it is theta means it is also going to be theta. Therefore, this is going to be t cos theta. This is going to be t sin theta. Did you remember resolution of a vector we discussed in basics? If it is a bar, by making an angle theta, horizontal component a cos theta, vertical component a sin theta. In basics we discussed about this resolution of a vector into two components. Now this is t cos theta, this is going to be t sin theta. Now mg is balanced by t cos theta. Now who is going to balance this t sin theta? Who is going to balance this t sin theta means between these two, which force is going to adjust? A repulsive force in this direction it is going to act. Therefore, T sin theta is balanced by Coulomb force. That is going to be force between A and B, which are separated by distance x. So, this x got separated by itself whenever you are suspending two similar objects. So, now at equilibrium condition, T cos theta equal to what we got here? mg. T cos theta equal to mg, like that. In horizontal direction, if you have seen T sin theta equal to what you got there? F Coulomb force. So that one only they will write F also. Now equation 1, equation 2, if you observe, equation 1 by 2. Equation 1 by 2, if you do, what you will be getting? Sin theta by cos theta. Tan theta equal to what you are going to get? F by mg. Tan theta equal to F by mg. So this is nothing but how much theta, how much angle this thing is making with the vertical. You have to remember this formula, not this derivation. Understood? Tan theta equal to F by mg. Once in laws of motion completed, laws of motion lesson completed means you will remember very easily this formula. Now what is F means here? Coulomb force between A and B. That is nothing but K Q into Q by x square into mg. Correct? This is nothing but F. K Q into Q by x square. Mg remains mj. This is going to be tan theta formula. Sometimes they will ask, what is the tension developed within this string? They will ask. Whenever tension developed within this string means you have to do like this. This formula also you have to remember. So from equation 1 and 2, if you do 1 square plus 2 square. So what is 1 square here? T square sin square theta plus 2 square means T square cos square theta is equal to right side F square plus mg whole square. So left side you can take common T square. So sin square theta plus cos square theta equal to F square plus mg whole square. So this sin square theta plus cos square theta can be taken as 1. Therefore, T square is equal to F square plus mg whole square. T is equal to root of F square plus mg whole square. So this is the tensional force. You have to remember these two equations. What is the tensional force developed in this string? So what is the angle it is going to make? So next, they are going to take entire this system into the medium or into the liquid or into water, like that they are going to ask. If entire system is going to be immersed in liquid, at the time, what is the new angle it is going to make? They are going to ask. At the time, how to do means, once you got idea of this one, you will get that one also very fastly. So tan theta dash you can assume in liquid, in other medium, tan theta dash. F will become. So that medium, within the medium, how the force is going to be changed. Already we discussed. In any medium, F medium is equal to F by K. Therefore, here you will write F by K. Now, how the weight is going to be changed within that medium? If you are immersing in the liquid, that liquid dielectric constant you have to take. Okay. So, F by K we will take. So, medium, liquid means weight is going to be written as apparent weight. Apparent weight formula mg into 1 minus dl by dv. So, this one you will get in fluids lesson. This one already we discussed. Therefore, you will get by using F by mg if you replace means with tan theta. So, tan theta by K into 1 minus dl by dv. This K is dielectric constant. This K is just constant 9 into 10 power 9. So, you should not get confused with this. So, if you know already apparent weight formula, it will become easy for you to understand. But first year students still they don't know. If they are doing only first lesson means they don't know this apparent weight formula. Already this one we discussed. So, this is nothing but tan theta dash is angle made by string in the liquid. In the liquid, or if you are writing liquid means water means a density of water by density of body they are going to write. So within the liquid how much angle making, same formula, just F you are replacing as F by K. Already this one we discussed, effect of medium on the force we discussed, therefore directly I wrote. This is apparent weight formula. In the water, in the liquid, weight of the object is going to be changed, therefore that formula is going to be this one. Now, to get same angle, what is the condition they are going to ask? To get same angle, what is the condition means? Tan theta dash should be equal to tan theta. Tan theta dash equal to tan theta by k into 1 minus dl by dv. To get same angle, to get same angle in both vacuum and liquid, what is the condition means? These two are going to be equal, therefore you can cancel. Then k is equal to 1 by 1 minus dl by dv. Just if you rearrange, you are going to get the answer. Okay, this is dielectric constant. To get same angle, what is the dielectric constant of that medium they are going to ask? At that time, you have to use this formula. So all these are equations for equilibrium condition of this suspended charge by insulating thread. Either they will ask angle, they will ask tensional force. Otherwise, what is the angle made by string within the liquid or medium, or what is the dielectric constant of that medium whenever both the angles are going to be same. So these are the concepts, and they may ask problem on that. Next, already we discussed this. This is an equilateral triangle. If you place three charges at three corners A, B, C. So find the resultant force on any one of the charge, either C, A, B. Did you remember formula? So what is the resultant force you got means? What is the resultant force you got? So F is equal to root 3 kq square by S. Correct? Did you remember this equation? So A is going to repel C in this direction, FA. So C is going to be repelled by B in this direction, FB. So resultant of these two, we got FC. This FC value is root 3 kq square by A square. Now, what is the question how they are going to ask means, to get equilibrium condition at C. To get equilibrium condition at C, how much charge we have to place at center of this triangle they will ask. To get equilibrium, how much charge we have to place at center of this triangle they are going to ask. If you place how much charge here, so resultant force at any one of the corner is going to become 0. Resultant force is 0 means it is at equilibrium condition. So already one force is acting away. So to get equilibrium condition, resultant force, next force should be acting in this direction. If you want to balance this, FC means equal and opposite force should be developed like this, in opposite direction, not in the same direction. If you got in same direction, force is going to become more. So these should be equal and opposite. To get force like this, here first we have to place negative charge. That charge value we are taking it as small q. Then what is the force between center placed charge and C? That is nothing but F is equal to, or F naught is equal to K into capital Q into small q by this distance, that is nothing but OC square. Already we discussed one day what is the distance from center to corner within the triangle. Did you remember? What is that small r? Small r is nothing but A by root 3. Therefore, K into capital Q small q by, so A by root 3 whole square. Isn't it? So if we are rearranging this, 3 K into small q into q by A square. So now this force should be equal to this force. If you are equating these two, what you are going to get? 3 k into q by a square. So if you cancel, whichever are going to be cancelled. So k, one q will be cancelled, a square will be cancelled. Then what is remaining? Q means root 3 capital Q divided by 3. Therefore, small q is going to be q by root 3. How you got root 3 here means 3 can be written as root 3 into root 3. So, this charge will be negative or positive? This charge will be negative. Therefore, q is equal to minus q by root 3. If you place minus q by root 3, then only it will be attractive. Otherwise, if you place plus q by 3, root 3 means it is going to be repulsive. This is the condition for equilibrium. Find how much charge should be placed at center of the triangle to get equilibrium position at any one of the corner. Resultant force at any one of the corner will become 0 if you place how much charge. Like this we have to do. Therefore, we have done this one previously. Same like this, they will give asked on square also. You can try this on the square. Find how much charge should be placed at center of the square. Is a negative or positive, you can cross check. If you place how much charge at center of the square, resultant force at any one of the corner is going to become 0 or equilibrium. So you can try that, otherwise we will see in next class by doing this. Maybe you people can do if you follow this correctly, but resultant force at any one of the corner you should remember. Okay, try that, otherwise we will do in next class. Thank you.